Now for part three of building mathematics, secondary math. All right, now we're going to talk about measurement. And so when we're talking about measurement, we're talking about concepts that are related to things like size, length, weight, volume, and time. Time is a form of measurement that a lot of people don't think of, but we do measure time, right? How long something lasts or takes, for example. So the teaching tools you're going to be using, and you had some experience with this last week, are standard and non-standard units of measure. You're going to be using hands-on manipulatives with your students, and then real life materials. If you're going to be measuring length and you can move to a ruler, let's do that. If you can then move from a ruler to a yardstick, let's do that because we want to really work on that generalization, right? When I measure, sometimes I use a ruler, sometimes I use a yardstick, and sometimes I use a tape measure because I'm doing a lot of stuff around my house right now. So you're going to see measurement across grades. And here's an example. This one is middle school. So for this standard, the student would use geometric shapes, their measures, and their properties to describe objects, such as modeling a can as a cylinder. Or when they're talking their measurement, they could describe it by talking about how tall or how wide it is. And so an actual example of this might be deciding which containers fit best or which container fits best for different items, such as which box is best to fit the cereal or which can would fit the tennis balls, for example. And so, measurement again is a wonderful way for you to connect math to real world context through things like baking or building or even timing your daily activities. You can work on the measurement of time throughout your day. How long does it take us to do this? How long between this activity and the next activity? So, again, I want you to think about when you're teaching measurement, how can I make this applicable for my students in real life context? So, when you're teaching measurement, you're going to teach students to do things like compare, to estimate, and to actually measure using hands on tools. So, again, don't shy away from those tools. Don't think you always have to stay at something that's fun, like the non standard units of measure. No, we want to move our students on as quickly as possible. And so, one activity you can do that is always fun and it ties math and science is to do something like build a ramp. If you want to see students have fun, build a ramp. And when you're talking about something like force and motion, and then roll balls or cars down it of different sizes, different weights, and then see how far they go. And then you can use that to tie. You could even measure the distance to tie math. And again, that's what we'll be doing is measuring, or you could use measurement when you're building the ramp. But that's a way for you to tie math and science together. So you're embedding math in science, or it could be the other way around. You're embedding science in math. And so you can really see how math supports science integration and applying that learning in another setting. So you think about another context. So you think about generalization. Science is a great place to work on generalization. And again, really encourage you to teach through real projects. Cook. That's a great thing to do. We don't want to cook all the time, but it's a great thing to do when you're doing measurement, for example. Building things. Again, that is fun. Let me just tell you fun. Build a house, build a robot. Your kids will love it. Your students will love it. And then timing activities, you'd be surprised. I know that some of you said that you just weren't used to measurement. And that was something you had not had much experience with. But the things you can do with measurement when you're teaching it really engage students. Um, I also wanted to point out, and I didn't do this earlier, is did you notice how the teachers in the videos that we saw were using story-based lessons, using a math story-based lesson? So I want to make sure that you think about that even when you're doing measurement. You could describe how to build something through a math story-based lesson, and then the students actually carry that out because it could include something like directions, right? All right, we're going to move on to data and, analysis and probability. And again, this is an area that a lot of times people don't think about our students in instructing our students on data analysis and probability, but our students absolutely can do it, and we have research out there to show it. So when you're doing teaching data analysis and probability, you're teaching things like collecting data, organizing data, and interpreting data. And it can be as easy as what do you want? What do you want for lunch today? And you graph everybody's choices. And so you're collecting data as you're having the students put what choice they want for lunch on there. You can have a bar graph where they put it, you already have, or a grid where they then build a bar graph. That's you organizing the data. And then you can look and see what did students want more? Did they want, a hamburger or did they want spaghetti? You're interpreting the data right there. So don't make it more difficult than it needs to be. So here's one of our DLMEEs. It's a high school one, and students will use data to make decisions or predictions in real life context. So we could graph the temperature outside over time, over the past week, for example, and then make a prediction of what do you think the temperature will be tomorrow. Here's an example of an activity you might do. So perhaps you have a math story-based lesson about a student who has started a YouTube channel. And so what the student's going to do is he's going to check his YouTube subscriptions and he is going to predict when he meets the next subscriber milestone. So when do I predict what date or how many days out do I predict it's going to take me to reach 100 subscribers or 1,000 subscribers, etc. So teaching tools that you're going to use when you're teaching data analysis and probability, you're going to be using graphs. And if you can use physical graphs where they actually can use those manipulatives initially, that is much more powerful than moving straight to something that's abstract. You can then move to pictographs. Pictographs would fall in that representational stage of the CRA, and that can help students understand the data. But again, you can use real objects when you're analyzing data to make it very concrete for students and then fade that off to more abstract concepts or more abstract representations. So again, when you're collecting data, I always encourage you to make it motivating for those students. If you have a student that loves football, we're going to collect some data on some football. And that is phenomenal. You have a student that loves music. Let's go on YouTube. Let's collect some data on how many views they have today compared to tomorrow, compared to the next day. If a student loves makeup, I used to talk about makeup because I taught kids who are starting to use makeup. Look at the prices. Let's do some data analysis of the prices. Is it more expensive at Walmart or do we think it's more expensive at where else would we go? Target. So when you're teaching data analysis, do things like have class surveys. That's a great thing. What snacks should we have Friday? And you can, when you're doing those surveys, you can do things like tally charts. You can create bar graphs, and never forget a pictograph, especially for our students who are at that level and need that. It's a really good representation of the data, and it's an easy way to collect data or with pictographs because you just put the pictures there, right? That's your collection of data. So an example might be that you graph the number of, or graph the number of each meal you're going to buy for Best Buddies movie night. So students have a choice of the meal that they want. Do they want pepperoni pizza or do they want cheese pizza, for example? And you're going to graph the number of meals that you need to get for each of those. We have, 10 students who want pepperoni pizza, and we have 5 students that want cheese. So, really using that hands on categorization, asking real life questions, and then having students extend what they're doing by having them read or interpret their results. And students can interpret their results using an AAC device. So, again, you can see that data doesn't have to, data collection and analysis and interpretation and doing probability, it's only as hard as you make it in your head. And this is where sometimes, I'll be honest with you, AI can come in helpful where you can say, I need to do some data analysis. Can you give me, here's what we're learning. Can you give me 5 or 10? I usually ask for something like, give me 10 examples of activities I might use. And then later on, you can start to devise those on your own. But in the initial stages of you as a teacher, you may need some kind of support. So now let's look at another not great video, but let's look at a teacher who is talking about data analysis with her and teaching data analysis. And you'll get to see her teach. Again, these videos are under Teaching to the Standards Math. So you can see this curriculum hits a lot of different areas, right? And since we're using their videos, that's why I'm doing this where I'm scrolling and stopping. I want you to be able to see what it covers. But we also want to thank the company for allowing us to access their videos.
Today, we're going to learn about math that we use to help us solve what? Problems. Going to mark our vote on a what? Bar graph. Good. The students know that they've never done this before. They know they've counted money. They know they've done time. They know, that they've learned about addresses and all the things that we use numbers for. But they've never really been expected to utilize it in a fashion like this that's what their brothers and sisters are doing or what their cousins and nieces and nephews are doing. Today we're going to read the story about students like yourself in Mr. Williams' class voting for their favorite book. What do we always vote for? Movies. Movies on Friday. That's what we vote for. How many? Or Lord of the Rings with how many? Three. Which one's higher? Lord of the Rings. Math, I like to do algebra and science. It allows them to be able to go home and say they're doing it, and I think that makes them proud. And I am proud to be part of it, and you won't know till you try.
And I think that's important to remember, right? You don't know until you try, and it is our job to try. That's what it is, because our students can do it. I mean, look at those students. They're doing it. If those students can do it, your students can do it. All right, so here is a task analysis or excuse me, not a task analysis, but a chart that shows the strands of math across the grade bands. And I just kind of want to give you a quick example so you can see how they're building on one another as students move up in the grades. So we were just talking about data analysis. If we look at this under data analysis, so I'm right here. Students are supposed to observe their surroundings, generate questions, and then choose information to answer those questions. And then they organize that information to communicate their findings because that's what you do is you observe, you generate a question, you collect data on that question, you organize that data, and then you interpret it and then communicate what you found out. So in the K2, you can see that students are collecting and representing data to show the exact representation of their observation. So it might be something like we were talking about, something like what type of meal do you want? Pepperoni pizza or cheese pizza? Or in this one, it says a chart listing each student showing the number of pockets that they're wearing. So that this is where you would graph the number of pockets that students were wearing in K2. Once you get up to 3.5, you might do something like a group your data on a chart, such as grouping the number of students with 2, 3, 4, and 5 pockets. So that's that categorization, right? We have students with 2 pockets, students with 3 pockets, and then you're going to graph that on your chart. Once you get up to 6th through 8th grade, you're going to start comparing data. So you might be doing things like looking at prices and sales of jeans with a specific number of pockets. And so again, you can see those skills scaffolding, they're building on one another. And then once students get to high school, they might do something like determine how to present the data, such as showing a distribution of gene sales by age group and report reasons for those preferences. Again, it just gets more rigorous and the skills are building on one another. All right, doing a quick check-in. What are your feelings about what did we just do? Measurement and data analysis and probability. Let me know how you're doing. Make sure that you write your questions in your discussion guide and or send them to me. And you're always welcome to ask them in class or meet with me before class or during office hours or at your own time if needed. Because questions are always, always, always welcome. All right, I will see you all in the next video.